So instead of looking at drawing the picture based on, or saying all the different things that have happened, they're going to tell us what happened, and they want us to write an equation, a new equation, based on our old one, and then draw it. Draw the new equation, that is. And so they're telling us that this is our original equation. Remember, that's inverse variation. And we're going to talk about what happened with this thing in an equation format and then in a picture format. So first, if I've translated up 2 units, that means I take that equation that I see there and I go y equals 1 over x. And to show that it went up 2 units, I write down plus 2. Because whatever is with the y is the same as what you think it would be. And then I can draw this graph, because it says sketch it afterwards. So normally, I have my horizontal asymptote at y equals 0, but now my horizontal asymptote is going to be at 2. So I put it over here, y equals 2. And my normal vertical asymptote is at x equals 0, so I just leave it there because it didn't move left or right. And then I graph this picture. I'm done. That's all there is to it.
Can we graph them?
In the next one, we want to go to the right 3 units. So this is kind of talking about the other part. In the first one, A, we went up and down. This one we're going to be going left and right. So right 3 means I'm with the fractional part, with the x. When I write that down, that means I have y equals 1 over x minus 3. So that's a translation of 3 to the right. I draw my coordinate axes to sketch it. And my asymptote, I know, is going to be 3 to the right, so I move that 3 units to the right. I know that's now at 3. My horizontal asymptote did not change, so I put that horizontal asymptote along the x-axis. That's my y equals 0 asymptote. And when I sketch this graph, since I moved 3 to the right, this is what my graph looks like. Now it might be helpful as you're doing these, maybe at the very beginning before you do any of this stuff, to draw a quick sketch of what this graph looks like. Because this is what our normal y over x, or 1 over x, pardon me, graph looks like. And you can see how the red and the orange graphs have moved either up or right from that original purple graph. This one. Okay, letter C. We're going to translate things down 1 unit and left 4 units. So as I write my equation for that, what I would write down is y equals, and I'm going to take care of the left first. So that would be 1 over x plus 4. And then to go down 1 unit, I'd go minus 1. So this stuff right here, the plus 4 is because I went left 4, and this stuff down 1 is indicated by the minus 1. And then if I graph that, I would take my down 1 unit to be right here. So this is at negative 1. And my left 4 units to be right here. So that's negative 4. And then when I graph this graph, I would see something that looks like this. Oh, no, I wouldn't. Sorry, my bad. Let's try that again. I would see something that looks like this. In this last problem, I'm going to draw the picture first, and I want to show you something kind of weird. So here's the picture. It says reflect our original graph, which we saw back at the top, over the x-axis. If I do that, then the one that was in the first quadrant comes down to the fourth quadrant, and the one in the third quadrant goes to the second quadrant. But we learned about this a little bit earlier. This was the graph y equals negative 1 over x. So it actually can be described as being reflected over the x-axis or reflected over the y-axis. The negative sign does whichever thing you want to talk about. It does both, really, because it's an inverse variation graph. Kind of strange. The strategy in letters 3a and 3b is to use what we call the means extremes theorem, which you might know as cross multiply, in order to solve the problem. So for example, in number 3, I see that I have these two fractions equal to each other, which means that we have a proportion. And so I multiply those two things, and I multiply those two things, and then I solve. So let's say that I'm doing the yellow first. If I multiply those two yellow things, that means I'm taking the 2 times the x and the plus 4, both. And if I multiply the two green things, that means I'm multiplying the 3 and the x together. And now we have an equation that we've set up that we're going to solve. So that's all that's going on with 3a, 3b, and 4, although 4 is a word problem. If I were to solve that, what I see next is the 2 has to be distributed to the x and the 4, so that means I have 2x plus 8 equals 3x. Bless you. Bless you. I could subtract 2x from both sides. If I subtract 2x from both sides, I have 8 equals x, and I'm finished. In part B, they try to mess you up, though. In part B, notice on the left-hand side there's no fraction. Yeah, there is. They're liars. It's 3 over 1. So don't let them fool you if they don't have a fraction there. Just put it over 1 and you're good to go. It's the same exact problem, really, with different numbers as it was in letter A. So really we have, in the beginning here, we have a 3 times parentheses 4x minus 10 equals, nope, sorry, my bad, 1 times parentheses 2x plus 5. Do you really need to put the 1 down? Nah, not really. But I just did for fun. If I simplify that a little bit, I'm going to distribute the 3 to the 4x and the negative 10. That means I have 12x minus 30 equals 2x plus 5. And this is going to involve moving some things around, so I'm going to do a couple steps at the same time. So put your pencils down, just listen and see if this makes sense to you. Let's talk about the x's first. I notice that I have 12x on the left and 2x on the right. If I were to subtract 2x from both sides, the 2x on the right would disappear, and on the left I would end up with 10x. So on the left I have 10x. So now I've gotten the x's on the left. That means I want to put the numbers on the right. That means I need to get rid of the 30. Since it's minus 30, I'm going to add 30 to both sides. If I add 30 on the left, it disappears from the left. If I add 30 to the right, I get 35. And then you just divide both sides by 10, and you end up with x equal to 3.5. Okay, now pick up your pencils and write. All right, kind of a bittersweet question at number 4, of course, because the NHL has their players locked out, so on that, but...
Wait, no, they just got back.
They did?
Like 2 days ago.
Oh, all right, well. I have something to say about that in just a little bit. Minnesota Wild had a record of 23 wins and 18 losses. So if you were to find out their winning percentage right now, the way that you would do that is you would say that they have a certain number of wins divided by a certain total amount, and that would tell you their percentage that they have. That's how you calculate your percentage as a team. So currently, what that's saying is that I have 23 wins out of a total of 41 games. But they want to win a certain number of games more because they want to get a winning record of 65%. So when they get done, they want to have .65. Now, in order to do that, they have to win a certain number of games. So if they play, let's say they played and won 5 more games in a row. What that means is in order to change this 23, I would have to add 5 to it, right? Because they played and won 5 more games. But I'd also have to do the same thing to the bottom, because that means the total went up by 5 more as well. Get what I'm saying? Wins went up by 5, as well as the total going up by 5. So in order to figure this out, what you have to do is you have to add a certain number of games that they win in a row to both the wins and the total to figure out this answer. And that's what makes this problem similar to the ones we were just talking about, is now we have 2 rational functions equal to each other, or in other words, a proportion. Don't forget that this 0.65 is really over 1. So as you solve this problem, what's going to end up happening is you're going to have the cross multiply thing again, and you're going to solve it. And I'm going to leave that to you to figure out, but I am going to tell you the answer, and you can check it to see if you actually get it. The answer, when you get done, is going to end up being 11 games. So I want you to try that on your own, and I just wanted to help you with the setup.